Ever since our founding in 1924, when we first started out as a spring manufacturer, we at Tohatsu have continued to expand as a global industry, meeting the needs of our customers with a steady stream of new products. Among the products we have manufactured, the Tohatsu Spring, a press die standardized in 1966, stands out. Ever since it was certified by the Japanese Standards Association, JIS, in 1976, it has continued to be a favorite with customers in a wide variety of fields spanning the entire press die industry. At Tohatsu, we launched production and sales of a Tohatsu ISO spring in 2005, with a view to expanding our standards development to accommodate the world market. Tohatsu produces excellent quality products drawing on our extensive knowledge base and our superior technology. Mount Fuji, the symbol of Japan. Tohatsu's Shizuoka plant is located in a magnificent natural setting decorated with cherry blossom trees in the vicinity of Mount Fuji. Let's now look at an overview of Tohatsu's advanced technology in the context of our spring production process. The Tohatsu Spring, a result of quality material specially selected by Tohatsu and the epitome of high performance and reliability. Tohatsu springs are made of chrome silicon steel to ensure high performance in applications such as vehicle valve springs and suspension springs. We have developed the optimal materials for Tohatsu springs through our experience with world-class wire rod manufacturers and our many years of joint development. We have achieved a high level of fatigue strength, unbeatable durability, and heat resistance of up to 200 centigrade. The materials we use are perfectly suited to the concept of the Tohatsu spring. Our extensive know-how and forming process technology make for superior materials. Next, a summary of the spring production process, which begins with the coiling process. The hardness of Tohatsu springs ranges from HRC 44 to 52. We produce our springs selecting a level of hardness appropriate to the individual spring specifications and applications. This is our state-of-the-art large-scale coiling machine. We can achieve perfect flexibility in roller processing of these hard materials through computerized controls. The process of coil processing involves subtle adjustments to each item to ensure that the spring dimensions and load meet the appropriate standards. At Tohatsu, we have been able to resolve each and every one of these issues thanks to the tremendous know-how acquired over the years. Before talking about heat treatment processing, let's look at the following basic knowledge about springs. First, during coiling processing, there is the stress of pressure on the inside diameter as the stress of tension mounts on the outside diameter. Once processing is completed, there is a tendency for the items to return to their original shape. There is residual tensile stress on the inside diameter and residual compressive stress on the outside diameters. Tensile stress occurs when the wire is held taut like this, causing a subsidiary fracture. In contrast, compressive stress helps guard against subsidiary fracture in the wire. Part of the critical know-how of spring manufacturers involves releasing the residual tensile stress and imparting residual pressure. Let's now move on to the heat treatment process. The spring is evenly heated in the heating furnace, and we reduce residual tensile stress levels occurring at the forming stage to 1/4 of their original levels. Wire strength is reduced when heated over 400 centigrade. At temperatures of less than 400 centigrade, residual tensile strength cannot be reduced to 1/4 initial levels or less. In addition, processing must be done over a holding time of 40 minutes or more. For these reasons, conditions of heat treatment of chrome silicon steel at Tohatsu are set at an ideal 400 centigrade and a 50-minute processing period. You have just seen that the residual tensile stress was reduced to a remarkable 1/4 of initial levels. Because residual compressive stress, which enhances durability, was extricated, we need to do the shot peening process next. Let's take a look at the shot peening process and its role. Shot peening refers to the process of expanding the surface area of the strands by hitting the surface of the springs with hard steel balls, which are harder than the strands. The reactive force that works to control the expansion is residual compressive stress, which greatly improves spring durability. Can you see how sufficient residual compressive pressure is placed on the inside diameter as well? This is the spring before the shot peening process. This is the spring after the shot peening process. As you can see, it has taken on such a nice shape that it is hard to recognize as the same object. A critical factor in shot peening is that it must be carried out in a way that's optimal for each particular spring. Tohatsu's outstanding know-how comes into play in determining the appropriate shot particle size, hardness, speed, timing, temperature, and facility control. Next is the setting process. Here we raise the elasticity limit by inducing permanent deformity, forming a spring resistant to drooping. Next, bearing surface grinding processing. Grinding is a very important process in controlling precision in springs. The precision of parallelism and perpendicularity in Tohatsu springs, as well as uniform future length, is a direct result of this process. Springs with poor parallelism and perpendicularity tend to buckle and deform under compression, and there is also a high risk of premature breakage. At Tohatsu, we now employ state-of-the-art grinding machines which, utilizing sophisticated technology, produce high-precision springs. Next, we move on to shot cleaning. Once bearing grinding processing is complete, the shot peening process is done once again. This enables us to remove burrs left over from the grinding processes and gives us the double shot effect. Next is the coating process. With the conventional spray coating process, it was difficult to achieve uniform coating for the entire spring, and there were many cases where breakage occurred due to rusting. In response to these issues, Tohatsu adopted anion electrophoretic coating equipment in 1995 to enable uniform coating of spring surfaces. The coatings used at Tohatsu do not contain any dangerous substances such as lead. Next, we move on to testing. Finished springs are checked for quality and performance with a battery of strict tests. This is the load attribute test. Employing cutting-edge testing equipment, we compile data from numbers and graphs and amass and manage this data with computers. This is endurance testing. We implement tough durability testing, keeping the user perspective in mind. We make sure our products can offer outstanding performance by repeating the various kinds of durability tests between 60 and 360 times every minute. Using state-of-the-art optical microscopes, we check the materials for quality, and we also conduct our own testing for fractures. This is a sample of a fracture. Our proactive efforts make sure that we are meeting the needs of our customers. Tohatsu coil springs that have successfully gone through this strict testing are controlled using barcodes and stored in our automated warehouses. At our automated warehouse, we accurately control inventory for more than 2,000 different varieties of springs, including items meeting JIS, ISO, press die, and general industry standards. They are then shipped to customers around the world. It has now been 80 years since our establishment. In order to meet the ever-changing needs of our customers, we at Tohatsu are in the process of establishing a worldwide sales network. We hope we have given you a better explanation of what we do. At Tohatsu, we're committed to taking the perspective of our users and to maintaining our tradition of offering the very best in springs.